Nottingham Trent University.
Medieval wall paintings, of course there are thousands of those surviving. People don't really know it, but they're usually in a very fragmentary and damaged form. This is an incredibly rare medieval wall painting. It's extremely high quality, but it's also relatively complete. I'm Jane Spooner and I'm the building curator at the Tower of London, and I work for Historic Royal Palaces. I first met Dr. Liang from Nottingham Trent University really when she approached us with an interest in looking at this wall painting. She was developing these techniques and wanting to work out how they would work in the field. She wanted to make her research relevant and useful. And so in order to do that, she needed to come and find sites where she could take the equipment and see how it worked in situ. Scientific investigation in general of medieval wall paintings is very useful, both in understanding how they were made, what they are, and also helping us come up with strategies for preserving them. But also non-invasive scientific investigation, of course, it is the ideal, because then we don't have to commit any damage. You know, the samples we would take from this would be no larger than the size of a pinhead anyway, but it's great if you can avoid doing even that.
We are trying to look at a 14th century wall painting in Bywood Tower using non-invasive techniques, and in particular we've got two instruments here. And one is called the optical coherence tomography. So it's a technique that was borrowed from medical imaging. It was first developed to look at 3D in vivo imaging of the eye. And we, in 2004, started using this on paintings. But we've never really scanned a wall painting before, and this is the first time that we're looking at a wall painting, and we're seeing different layer structures. So the technique basically allows you to be about 1 centimeter away from the painting and be able to probe into the painting whilst you are actually away from the painting, so you're not touching it. And you're getting different layers, for example, varnish layers, overpaint layers, and different, in some cases, different paint layers as well. So it gives you the internal structure of the paint without having to cut a bit of sample out, which is what people will have to do otherwise. So just to give you an idea of scale, from here to here is 1.6 millimeters. This is the surface, the very bright line in the surface, yeah? And then there's a very faint layer there, and then there is some sort of faint transparent layer which may correspond to a varnish layer. The other piece of equipment we were using at the Tower of London was the portable remote hyperspectral imaging system. We call it PRISMs. And it's a remote hyperspectral imaging instrument which we developed a few years ago in our own lab. So what it does is that you can just put it on ground level and look at a painting far away at high resolution and collect images at different spectral bands. If you think about the rainbow, had different colors. So we are collecting images at those different color bands, if you like. We can scan somewhere in the visible part of the spectrum, that is the part of the spectrum that our eyes can see. And then we can also probe into the near-infrared, where most of a lot of the paint layers becomes transparent, so it can reveal the preparatory drawing that might have been done below the painting.
It's the fact that it's such an important example of a work of art, and it's so rare. It's of national and international significance. It's very important for our heritage really to know more about it, to know as much about it as possible, and then to use that information to help us preserve it for future generations.